Hello, welcome to Humble Virtuals. I'm your honest teacher Mike, and your academic success and excellence is my priority and business. Today we are looking at linear motion, and the subtopic we are tackling is velocity and acceleration. Now, what is velocity? Velocity is the rate of change of the displacement with respect to time. It tells how fast an object is moving and in which direction it is moving. In simple terms, velocity is speed in a specific direction. For example, if you talk about speed in 60 meters per second, then you think about to which direction. So 60 meters per second towards east, or 15 kilometers per hour southwards. When we have direction involved and speed is also involved, in this case we call that particular quantity velocity. So velocity, by the formula, velocity is distance over time. Displacement, in other words, is the shortest distance between the starting and the ending points. The time is the duration of travel. Velocity is normally measured in meters per second or kilometers per hour. Acceleration, on the other hand, acceleration is the rate of change of the velocity with respect to time. It shows how quickly the velocity of an object increases or decreases. Have you ever seen or have you ever observed a vehicle moving? So a vehicle will always start from rest. Then the speed will be increasing at a given rate. At some point, it will maintain that speed and move over a given distance for a given time. Now, when the vehicle is coming to a rest, speed is going to reduce constantly until it comes to a rest. The process of reducing the speed is called deceleration, and the process of increasing the speed is called acceleration. So acceleration is either decrease or increase. What is the formula for calculating acceleration? Acceleration is given by final velocity minus initial velocity over time. Acceleration is measured in meters per second square. Example 1. A bus starts from rest and accelerates for 20 seconds to attain a velocity of 60 meters per second. Calculate its acceleration. The formula is final velocity minus initial velocity divided by time. So in this case, our final velocity is 60 meters per second and the initial velocity is 0. Why 0? Because from rest, if the vehicle is not moving, the vehicle is at rest and therefore the speed is 0. So that is why initial velocity is 0 meters per second. It accelerates so that it attains a velocity of 60 meters per second. 60 meters per second becomes the final velocity, and the time is 20 seconds. So applying the formula, acceleration is equal to final velocity minus initial velocity over time. So that will be 60 meters per second minus 0 meters per second divided by 20 seconds. 60 minus 0 is 60, so 60 meters per second divided by 20 seconds, and that one gives us 3 meters per second square. Question number 2. A bus which was moving at a speed of 30 meters per second accelerates to attain 120 meters per second in 15 seconds. Determine its acceleration. Final velocity is 120 meters per second. Initial velocity is 30 meters per second and time taken is 15 seconds. So therefore, acceleration is going to be 120 minus 30 divided by 15. That one gives you 90 meters per second divided by 15 seconds, and that one acceleration is 6 meters per second square. Question 3. A bus which was moving at a speed of 70 meters per second notices a roadblock ahead. The driver applies the brake so as the bus comes to rest after 20 seconds. Then determine the rate of deceleration of the bus. As we said earlier, when the speed is going down so that the vehicle comes to rest, we call that deceleration. So the formula remains the same, but the value of the acceleration will be negative because the speed is going down. So now in this case, when it comes to rest, the speed is going to be 0 meters per second. So that becomes the final velocity. Initial velocity is 70 meters per second, our time is 20 seconds. So therefore, deceleration will be final velocity minus initial velocity over time. So therefore, that is going to be 0 meters per second, subtract 70 meters per second, divide by 20. That gives you negative 70 meters per second over 20, and that one gives you negative 3.5 meters per second square. Now, example 3, I would wish that you do on your own. It reads, a bus was moving at a speed of 40 meters per second after 10 seconds and 60 meters per second after 50 seconds. Determine the rate of acceleration. Question 5, which you should also work on. A bus accelerates at the rate of 2.5 meters per second square for 20 seconds. Determine the velocity after acceleration. Okay. Question 6. A motorbike accelerates from a velocity of 20 meters per second for 15 seconds at the rate of 1.5 meters per second square to attain a maximum speed. Determine the maximum speed. Question 7. A bus which was moving at a speed of 60 meters per second brakes uniformly at the rate of negative 6 meters per second square in order to come to rest at the bus stop. Determine the time taken to come to rest and the distance covered during the deceleration. Work on that. Now, let us move to the next stage. Velocity time graph. Velocity time graph is a graph that shows the rate of change of velocity over time. It is drawn by plotting velocity against time. Examples: a car starts from rest and accelerates uniformly to attain a velocity of 60 meters per second in 10 seconds. It maintains its speed for the next 15 seconds, then decelerates uniformly to rest in 5 seconds. Part A, sketch the velocity time graph. So we have the y-axis and the x-axis. On the y-axis, we plot velocity, and velocity is measured in meters per second. And then on the x-axis, we plot time. Time is measured in seconds. Then we're told that a bus starts from rest. From rest, time is 0 and speed is 0. Then it accelerates uniformly to attain a velocity of 20 meters per second in 10 seconds. So in this case, you don't have to use scale, but we are going to sketch because we're told to sketch, so not drawn to scale. So assume this is where we have 20 and this is where we have the time 10 seconds. So we are going to look at where the two lines meet. It will now give you the point to plot. Then we are told that it maintains its speed for the next 15 seconds. So from the time 10 seconds, you add 15 seconds to it, it takes you to 25. Meaning from that point, the speed 20 meters per second was maintained from the time 10 seconds up to 25 seconds. So we draw a straight line, a horizontal line between those periods, and then we find where they're going to stop. From the speed of 25 meters per second, it goes down, the speed goes down, so the speed will be falling down until it comes to rest, until it is touching the x-axis, and and then the difference between the speed at the time at 25, the next time is 5 seconds. So 25 you add 5, it gives you 30. And then this becomes our velocity time graph. From the velocity time graph, we are told to answer the following questions. Part 1. Calculate Roman 1. The acceleration during the first 10 seconds. So acceleration is when the speed is increasing. So it is happening from the time 0 to the time 10 seconds, and the speed or the velocity at that point is 20. So the initial velocity in this case is 0 meters per second, and the final velocity is 20 meters per second. And then time taken from 0 to 10, the difference is 10. So acceleration is equal to final velocity minus initial velocity divided by time, and that is going to be 20 minus 0 divided by 10, and our acceleration will be 2 meters per second square. Part 2 of that question, the deceleration during the last 5 seconds. Deceleration is happening from the time 25 seconds to the time 30 seconds. The speed is coming from 20 meters per second to 0 meters per second. So therefore, initial velocity is 20 meters per second. Final velocity is 0 meters per second, and total time taken is 30 minus 25, which is 5 seconds. So therefore, deceleration will be 0 minus 20 over 5. And this one, you get negative 20 divided by 5. This gives you negative 4 meters per second square. Then part 2, the total distance covered by the car. Now, to get the total distance covered, you determine the area of the shape formed. Then you need to know the shape, and then you apply the normal formula for finding the area of the shape. In this case, our shape is a trapezium, and we need to know the parallel sides. The parallel sides are from the beginning from 0 up to 30. That becomes our first side, parallel side. The other side is the difference from 10 to 25, and that one gives us 15. And then height is the vertical height, which is equivalent to 20. So therefore we apply the formula. Area is equal to a half into a plus b by height. So therefore that is going to be a half into 15 plus 30 times the height, and the height is 20. So therefore it will be a half by 45 by 20, and that one gives us 450 meters. I want us to look at example 2. A motorbike is moving at a constant velocity of 15 meters per second for 8 seconds. It then accelerates uniformly to 25 meters per second in 4 seconds before immediately decelerating uniformly to 0 meters per second in 6 seconds. We are told draw the velocity time graph. So of course on the y-axis we are going to have velocity in meters per second, and then on the x-axis we have time in seconds. So therefore it is starting from a speed. Here is a different situation. This observer was able to notice that the speed of motorbike from the beginning was 15 meters per second. So at the point when time is 0, the speed is 15 meters per second. Then that speed was maintained for 8 seconds. So we shall go along the line. We draw a horizontal line from 0 to 8, and then we stop there, and we have the first part. And then we are told that after the 8th second, it accelerates uniformly to attain a speed of 25. So from 15, the speed is increasing up to 25, and the time taken is 4 seconds. So therefore from 8 you add 4, you get to 12. So therefore, and then from 15 to 25 we need to add 10, so that we get 25 at that point. And then after that, the speed is now coming down up to 0. So it is coming to rest at 0. The time between 12 to the point when it is coming to rest is 6 seconds. So it is 12 plus 6 to give us 18. So now to answer the first question, calculate the acceleration between the 8th and the 12th second. So initial velocity is 15, final velocity is 25, and time taken is 4 seconds. So therefore that is going to be 25 minus 15, which is 10, divided by time 4. So therefore that gives you 10 divided by 4, and that gives us the answer to be equal to 2.5 meters per second square. The next part, the deceleration between the 12th and the 18th second. So final velocity is 0 meters per second, initial velocity is 25, and time taken is 6. So that is going to be negative 25 meters per second divided by 6 to give us negative 4.167 per second square. Distance is equal to the area of the shape formed, as we said earlier. So therefore, area of the shape formed is, we have that we can divide this shape into 3 different shapes, where we have the first part is a rectangle, the next is a trapezium, and the next is a triangle. So the area is going to be length times width plus a half into a plus b by height plus a half base times height. That is going to be 15 times 8 plus a half into 25 plus 15 by 4, and then plus a half into 25 by 6. That gives you 120 plus 80 plus 75, a total of 275 meters. Question number 3. A train starts from rest and accelerates at 0.5 meters per second square for 40 seconds, maintains the top speed for 60 seconds, and then accelerates uniformly to stop in 20 seconds. Part A. Determine the maximum velocity. The maximum velocity is that velocity that was maintained for 60 seconds, and it is the same as the velocity after 40 seconds. And acceleration is 0.5 meters per second square. So already here we are given acceleration, we have time, and we have the initial velocity. So we only need to find the final velocity after 40 seconds. So we are going to use the formula that acceleration is equal to final velocity minus initial velocity over time. In this case, we already have the acceleration 0.5 meters per second square is equal to final velocity, which we don't know, minus initial velocity, which is 0 meters per second, divided by time, which is 40 seconds. So therefore final velocity will be given by 0.5 meters per second square times 40 seconds, and that one gives you 20 meters per second. That therefore means the maximum velocity was also equal to 20 meters per second. Sketch the velocity time graph. It is starting from rest, speed is 0, velocity is 0, time is 0. It is moving up to a maximum velocity of 20 after 40 seconds. So therefore the combination of 0 to 20 and velocity 40, they meet at that point, and then the speed was maintained from 20. The speed was maintained, the speed of 20 meters per second was maintained. So we draw a horizontal line. It was maintained for 60 seconds. So that is going to be from the 40th second, add 60, it takes us to the 100 seconds. After that, it decelerates to stop in 20 seconds. So therefore, from the 100th second, you add 20, it gives you 120, and therefore it comes to rest at 0 from that point to 120 points. So therefore we bring it down at 120 seconds. That becomes the velocity time graph obtained. Number 2, deceleration rate. That is final velocity minus initial velocity over time. final velocity is 0 meters per second. Initial velocity is 20 meters per second. Time taken is 20 seconds. That is negative 20 meters per second divided by 20 to give negative 1 meters per second square. The total distance traveled by the train is equivalent to the area of the shape formed, and that is going to be a half into a plus b by height, because it is a trapezium. In this case, our a is 120, b is 60, and height is 20. So that is going to be a half into 120 plus 60 by 20. That is same as a half by 180 by 20, and that one gives you 1,800 meters. Now the next questions I want you to try by yourself. That is example 4, and it reads: a cyclist traveling at 12 meters per second accelerates uniformly to 20 meters per second in 5 seconds, then continues at this speed for 10 seconds before coming to stop in 8 seconds. Part A, draw the velocity time graph. Part B, calculate the acceleration during the first 15 seconds. And the next part, deceleration during the last 8 seconds. Then the final part, total distance covered. The next question: a bus moves from rest, accelerates uniformly for 12 seconds to reach 8 meters per second, then travels at this speed for 15 seconds before decelerating uniformly to 6 meters per second in 9 seconds. It then continued at 6 meters per second for 10 seconds. Draw the velocity time graph. Part A. Part B, calculate the acceleration in the first 12 seconds. The next part, deceleration between 27th and 36th second. Then total distance covered by the bus. Work on that, drop your answer, and it's my goodbye.